Hello class, today we're going to be focusing on the section 9.4 law of cosines. So to start off, let's even see if we even need to learn this because you know what, law of sines has been working out really well. In this case, I want you to solve the triangle below. And I would say stop and take a moment to try it out. You can still do that if you like, feel free to pause the video. But if I begin setting this up, you're going to see a problem, and let's do this in this color, sine of, let's say, b, because b is given, over b equaling, and I can pick either side c or a. Let's just pick a. I'm going to use sine of a over a here. We have a slight problem immediately that you can see as a is given, so let me check this off. So a is given, check, check. Sine of b is given, so check, check, but now we have the problem here of this one, sine of a, which is referring to this angle not given, and side b, which is referring to this side, which is also not given. So with that all being said, we can't use this method. We have to switch and try to use something else. So we will use the law of cosines. Now typically I love showing you guys how to prove stuff and so there's no memorization. Gosh, I hate that word. But in this case I'm going to have to jump to that. You can check out one of my other videos for the proof of law of cosines because otherwise this video would be too long. So since we have one equation and we have two variables, we can't use this. I'm going to get rid of it. And let's get rid of these. So the law of cosines is actually a very simple formula. Let me write it over here at the top. The law of cosines is a variation of your Pythagorean theorem. One way of writing it is this method. A squared equals, and this is where you'll write b squared plus c squared, and this is where it actually starts getting different, minus 2 BC, I know, hold on, multiplied by cosine of angle A. So I know this, I'm going to point to it, that this area here looks really, really weird. But I swear that this is just very simple, that you have the negative 2 multiplied your side B, which you already have, you're given your length for this, so multiply that 2, multiplied by cosine of angle A. So you actually have four things multiplying here, 2 multiplied by the B, multiplied by the C, multiplied by the A, and that's all subtracted from this summation here. Alright, so I'm going to keep writing, and there's different variations of writing this. You actually have, if you're looking, oh, and I should have said, you're solving for A here, typically. So if I'm solving for B now, it actually looks very similar. You have A squared now, and what's remaining, C squared, and it's actually 2 multiplying by your known sides. So AC and cosine of the given angle, which is B. Now you might say, how did I know this? This is typically used when we're noticing that we have a situation of side, angle, side. Notice that law of sines doesn't work there. So when you have side, angle, side, and we'll find out that you're going to use this for, so let me write this, SAS, you can use it for that or SSS, and we'll do that in our next example. But let's focus on the SAS for now. Oh, that was horrible. There you go. Alright, and if we look at C, you should try and fill that out on your own. You're going to get C squared equals, in this case, A squared plus B squared minus 2AB cosine of C. So those are the three variations of the law of cosines, and we will be using this to help solve our triangles, especially of SAS or SSS, side, angle, side, or all the sides are given. So let's solve this now. So to start off, let's pick out which one works best for us. I'm going to say for me that we're going to look for side B in this case, since we're given angle B. So we're going to be saying B squared equals, a squared plus c squared minus 2ac cosine of angle B. So in this case, we're still looking for b squared. And I'm going to assume everything's in inches. I just don't want to forget that. So units are important. Don't get me wrong. I'm just not going to write them. 27 squared minus 2 times 21 times 27 multiplied by the cosine of the angle, which is 101 degrees. Okay? And you're going to want your calculator for this. So b squared, we haven't gotten to square rooting that b yet, so we're just going to do 21 squared plus 27 squared, and subtracting from that sum is, be very careful how you type this in your calculator. You do not want to mess up any of your parentheses because you'll have to type everything back out. So just be very careful. I'm counting all my parentheses. You can't really see my work here. You're going to get an answer that's approximately 1386.38. And you take the square root of that, and you get approximately b equaling, this is where I'm rounding, 37.24. No, 23 actually. Undo. And my answer for this is actually going to be 37.2. Don't like I'm making my 7 squiggly. 0.23 inches. Don't forget the inches. Don't forget your units. All right. So now what you might say is, okay, wow, I got to do law of cosines for angle C and angle A to solve them. No! Gosh, no. What you want to do is probably use a different law. Hint. Law of sines. That might be easier for this. So, sine of, let's say if we're solving for A now, sine of A over A is equal to, and let's use what was given, sine of B over B. We were solving for A, or angle A in this case, so that's going to be sine of A equaling A sine B over side B. And you're going to take the arc sine of this, so angle A is now equal to sine inverse of A sine of angle B over side B. And let's plug that all in. Almost there. Making our way. Where are we? Where's A? Yes, 27 inches. There we go. I'm not going to write the inches here. Just going to keep that in again because it's very cumbersome to write that right now. 101 degrees divided by side B, which is 37.23. And you get approximately 45.39 degrees. And this is going to be your angle A. Let me put that in, 45.39. Okay, and let's do angle C, and I'm going to do that in a different color. Let's make this red, because why not? And here, this is where, again, I'm going to be using law of sines here, because that'll be easier than doing the other one, law of cosines. Side C, and sine of B over B. We're looking for angle C, so angle C, I'm going to skip some steps, oops, is going to be equal to sine, or arc sine of C sine, side C multiplied by sine of B over B, and plug in that information. So C is going to be equal to 21 sine of angle B, which is 101, over B, which is 37.23. Remember, this is all in inches. Don't forget that. And you're going to approximate to get 33.62 degrees. And that's going to be angle C, 33.62 degrees. And there you go. Those are your answers for solving this triangle. Alright, now let's do another. I know, it's just what you always wanted. More problems! So, we're going to be working with... Alrighty, so we have to solve the triangle here. And in this case, we're given each side length. And, well, it's not drawn to scale. But I'm going to mention you might want to think, okay, let's try law of sines. But the problem is with law of sines, you need a ratio of angles to sides. Since we have no angles, we can't use that. So one bet is to actually try and say, well, let's just try law of cosines. So if we say that we have c squared, I'm just picking that one arbitrarily, a squared plus b squared minus 2ab cosine c. Well, the thing is, let's just check off what we have so far. We're given this, great, we're given this, we have this, we have this. The only unknown is this one, angle c. So yeah, we have one equation, one unknown, we can do this. So, in this case, let me undo all those check marks. Okay, and let's plug these in. So in this case, what I'm going to do is you could reorganize it or plug in immediately, then reorganize it. I'm probably going to just reorganize it from here and then plug everything in. I typically like to do all my calculations at once. So in this case, I'm going to subtract the a squared and b squared. You're going to get c squared minus a squared minus b squared on one side of the equation, and leaving 2ab cosine of c. Now, I am also doing it this way because I know a lot of you actually dislike using your variables and manipulating them, but it's a skill set that you guys have to get used to. So I'm hoping you can follow along. Please pause the video if, let's say, this past step was confusing for you and try to figure out how I did it. Okay? So in this case now I'm going to get rid of the negative 2 and the negative 2ab by dividing by it. You don't add it because there's multiplication over here. You don't add it. You're dividing by it. So in this case, the next iteration of this is going to be c squared minus a squared minus b squared divided by negative 2ab equals cosine of c. The adding of the 2ab to the other side of the equation is typically what I see as an error or misconception of students making, so please be careful with that. And so at this point, I can actually just say, I take the inverse cosine of this whole thing, and then I can just plug in my knowns and actually get a single answer for angle C. And by the way, like I said, if you don't like this method, feel free to just plug it in at the beginning and manipulate the numbers. But I like being able to see it as, hey, what is angle C just equal to if I can plug in any given term? So in this case, now I'm going to plug in the numbers. You're going to get c squared. That's going to be 28 squared. I'm not going to include the units here. Not that I don't care. I like the units. They're my friends. 15 squared minus the 17 squared over negative 2 times 15 times, and this b, which is 17. I'll close that, and you're still getting this angle C, and now this is where we get approximate, because I'm going to be rounding here for angle C. And you get approximately an answer of, after you do it all out, 121.97 degrees. You could have rounded that to 122 if you'd like. I just noticed I forgot a parentheses down here. There we go. Fix that. But yeah, so that's what you get for angle C. So if you notice, my triangle is not set up correctly here. Probably should have moved around C to another one. I drew C as an acute angle. So let's see if I can redraw this really quick. Actually, let me draw it in yellow. 28 yards. Let's see, I'll make this 15 yards and 17 yards. And this is A, B, C. And type this in as I'll just round it 122, just for the sake of space. Ixnay on that one. Alright, so let's keep filling in the blanks. Now, you could, again, just plug in law of cosines for the other two. That seems tedious, especially when we're now given a lot of information. So I would use law of sines here. And as I'm ironing this out, I'm going to mention, with law of sines, well, let's just say we're looking for angle A now. So I'm going to type in sine A. One of the things with actually using law of sines is we had this ambiguous case when we had ASS, or angle side side. So the problem is, even though we have this information, right, that doesn't actually, or we have to watch out for that, I should say. We don't have that issue with law of cosines. Law of cosines is just you plug it in. So sine of A, I mean, that's what makes it nice, at least. So I'm looking for A. Angle A is simply going to be arc sine of A sine C over C. And before I shove that in my calculator, I'm going to 15, I'll just plug in the numbers, 15 for A, sine of 122 degrees approximately, and side C is 28, approximate for angle A, and you get about 27 degrees approximate, and that is angle A. So angle A is 27 degrees. Alright, let's do our last one. This is going to be sine C. Oh wait, no, yeah, well, I'm going to be using that one anyways. Sine C over C is equal to, now we're looking for angle B here. And again, B is just going to be simply equal to, undo that, arc sine of B sine of C divided by, oh, I should draw that in calculator. There we go. Over little c. And that is going to be your plugging in values here. So let me look for that. Sorry, I zoomed in too much. And arc sine B is going to be 17. Right? Okay. And, oh, did I use the wrong one for A? No, I see use 15. Okay. And sine C, sine of 122, approximated. And side C is 28. Yeah. And you're going to get approximate value. You get approximately 31 degrees for angle B. And so that's how you use side, side, side. Law of cosines, very helpful. A lot of work, I know, but very helpful. So I hope you enjoyed this video, and I will see you all next time.